Hello, everyone. I'm Stephen Lawton, Special Projects Editorial Director for SC Media, and your host for today's webcast, 0 Days and Counting. Today's webcast is sponsored by Capsulate. 2020 webcasts are a production of the SC Media Editorial Department. You can think of this as a fireside chat with a subject matter expert on a topic of interest to security professionals. This is not a product pitch. With that said, let's move on. Please join me in welcoming to our studios John Viega, co-founder and CEO of Capsulate. John's experience is in the building of defensive systems to protect against the exploitation of previously unknown vulnerabilities. Most recently, John was the executive VP of cloud service provider SilverSky, transforming it from a managed service provider to a cloud security company. Following the acquisition of SilverSky by BAE Systems, John went on to serve as the executive VP of products. Prior to SilverSky, John was the SaaS CTO at McAfee. He is an award-winning author with a half dozen books to his name, including Building Secure Software and Network Security with OpenSSL. He also co-designed GCM encryption mode, which is used by more than 70% of encrypted web traffic. There will be a Q&A following the presentation, so we encourage you to type in any questions that you might have for John via the interface. Welcome, John. Let's get started. With the zero-day vulnerability hitting the headlines, alarms sounding throughout the industry to figure out how to protect yourselves against them, 0 days have become a real problem. But long after the frenzy dies down and the attention has moved on to the next vulnerability or breach, the true impact of that 0 day can really take hold. Patching has proven to be both resource and cost intensive and is often not necessarily as effective as we want it to be. In this webcast, we'll look at how companies are still fighting the battle of 0 days, disclosed months ago and in some cases even years ago. Old attacks still harm us a lot. We know what a 0 day is, John. The problem, of course, lies in how to detect something we've never seen before and defending against it. So aside from waiting for someone in the media to say that there's a new 0 day or finding out when it hits your company, what should a CISO do to build defenses against such attacks? And frankly, are they far more prevalent than they should be?
Well, first, thanks for having me. I think that the way that most CISOs look at it is a belt and suspenders approach. They are looking for as many approaches to dealing with 0 days as possible, and it's a mix of prevention and detection strategies. On the prevention side, the move to the cloud has driven a lot of that to the software development lifecycle, and that makes even more sense given that in many companies, even their custom-built software is usually 90% based on open source these days. But the detection side is really where people have been falling down, and the cloud doesn't make that any easier. In terms of the defenses against those attacks, that's where things aren't working very well. Once you've got 0 days in open source, they can impact dozens of vendors. Image Tragic was one big one for a lot of Silicon Valley companies. For instance, it was a bug in the magic image processing library, and it was very easy for people to trigger and impacted a lot of different Valley companies. So, I think that in terms of how people deal with it, another problem is you also have to detect things that aren't 0 days, and that all generates a lot of noise, and sifting through the noise is pretty important. to the kind of the fundamental issue, though, of how do you detect something that you don't know about, that is actually pretty tractable. I think that there are very few innovations in the black hat world. They come at the rate of a few a year, and that's actually much easier to keep tabs on than the hundreds of thousands of bugs that a vulnerability scanner has to keep up on.
The life cycle of a zero-day is pretty basic. Attackers will scan for vulnerabilities, identify the security holes, write an exploit, infiltrate the system and launch the exploit. As I say, it's pretty basic for launching a security breach. Question is, why are so many people caught off guard? Surely the IT teams are scanning their own systems for these breaches or potential breaches as well, these vulnerabilities. And I'm wondering why these attacks or potential attacks are not identified long before the bad guys get to it. I'm surprised that the good guys don't find it first. Talk to me about that, if you would, please.
Yeah, look, scanning for problems is scanning for known problems, not zero-day problems. So you pretty much are going to expect that no matter how much prevention you try to do, you're always going to need both the belt and the suspenders, and be investing in detection as well. The scanning approach just has never worked that well to begin with, and it gets a lot harder as software is getting more ephemeral with kind of continuous deployment of software too. So I don't think anybody had the expectation ever that it was going to find everything, and the challenge is if you can keep tabs on the new stuff, that might get you most of the way there, but then the zero-day problem, especially if you're actually being targeted, is really the challenge, because it's not only very difficult to get ahead of, but if the attacker beats you, then you might have, they can often stay undetected for a long time.
Well, let's look at one particular real-world example, Heartbleed. The vulnerability that really took our industry by storm back in April of 2014 is as relevant today as it was back then, because, people are still missing the opportunity to stop it. We're still facing some serious security implications. Why are so many companies vulnerable to some of these years-old attacks, whether it's Heartbleed, Locky, or, pick your favorite attack? A recent example, the Jquery file upload vulnerability has been around for 8 years now. What are companies missing that they should be doing to protect themselves?
Well, sometimes, like with the Jquery example, it can be around for a long time, but people didn't know about it. And so if your scanner isn't picking up, there's really not much the typical organization is going to do about it. But for things like Heartbleed, where we still see that as an issue, sometimes it's because people are woefully undereducated, but often it's because they've done the risk equation, and it is more dangerous to patch than to run vulnerable software. And I think that we're watching a lot of people go through that calculus right now with Spectre and Meltdown. I hear plenty of people saying, have you ever seen anybody using this in the wild? Because our assessment is it's very, very unlikely to impact us, and the cost to upgrade everything to defend against it is so high. And you can see that when you go into data centers, people don't want to upgrade across major versions of their operating system because it can kind of impact the workload that it's running. You know, the move to the cloud and kind of containerization will help that over time, though. But that's certainly a large part of the problem is people have taken a calculated risk, and as much as we security folks want security to be the number one concern, it's usually the performance and reliability of their workload come way before the security.
Yeah, well, again, it's business people that are making those decisions, and profits often do come before security. I'm wondering, and I honestly don't know whether you can address this, but with some of the fines that companies are facing now, with GDPR, they can face up to 4% of worldwide revenue if there's a breach, and it's something that they could have fixed. That's one of the important data points in GDPR. If you could have fixed it and you chose not to, your fines are going to be significantly higher. Are some of these, new compliance requirements going to change this equation, where we'll see companies starting to patch more because the financial side of that equation is changing?
Well, again, I think that it really remains to be seen because there are a lot of other compensating controls that you can put in place that can address those issues. And so you have to have a reasonable sense that the economic impact of patching is going to outweigh the cost of patching, and that usually is the case, but in some instances where the risk is tremendously low or the impact isn't that high, then people have definitely made decisions that you and I typically wouldn't make. So GDPR might impact that, but the people are making best efforts that include like data encryption and a bunch of other things that I think they would try to point to as making a best effort.
Well, I guess we'll have to wait and see what the fines are before we start worrying about that. We've said it before, and it bears repeating. Antivirus, if I can borrow a phrase from a 1960s era theater of the absurd play, it's a useless precaution, but absolutely necessary. Aside from compliance and insurance and legal reasons, why you need AV software, it still protects you against some of these older attacks that we were talking about that just sort of keep coming back. Why are so many companies falling for some of these, older attacks, 20-year-old, 15-year-old attacks that simply running AV software might well have been able to prevent? We talk about endpoint detection and response and security appliances. Would they be more effective than just kind of gambling and not running your AV at all? And what security software from ISPs, for example, would help small businesses?
Well, on kind of the desktop, most enterprises have AV as a policy, and it's running most places. So if there's a lack of detection, then it really is the antivirus products failing. In people's production infrastructure, often people are running antivirus but believe it's doing nothing but ticking a compliance box, and that's often, particularly the case in the public cloud, which is mainly Linux-based, and where antivirus is traditionally not played, and moreover, antivirus as a category, the game is spot the bad binary, and in Linux you don't need to bring bad binaries to to get on and persist because Unix provides lots of little tools. So AV in and of itself is not really that effective in a production environment, and in a Windows environment, like AV has always been kind of a pretty broad umbrella that people have a pretty low opinion of, but I think that people have an overly simple view of what's under the hood, and realistically, as technology has progressed, any kind of technical innovations still get lumped under the hood of the antivirus because that's the easy way to explain it. And I think that the EDR is really going to end up rebranding antivirus with some expectations that the technology can actually start to do a good job, especially when detecting zero-day attacks. And that's really been the problem with the antivirus industry for a long time, is that it's hard to generically detect zero-day attacks, and the antivirus approach was traditionally start by trying to enumerate all of the bad executables. So the modern approach is to look at the things attackers have to do in order to get onto your system, or the things that they want to do when they're on your system, and that's a much smaller, easier to enumerate set. And if you can get out in front of it that way, you can hopefully do a much better job.
I'd like to take a moment here to remind our visitors that you can send John questions through the interface. We'll get to as many of them as we can towards the end of the broadcast. So, without talking about specific products, what does a company need from a technical and personnel standpoint to best be able to identify and battle 0 days? What would your SOC require, for example, and what level of training do you really need your staff to have to effectively defeat 0 days?
Yeah, this is a really big area of discussion for me, because I think that Google has even said that many people expect artificial intelligence is like a magic dust they can sprinkle over everything and get good results. And what we're seeing in the security operations world, and really in security products in general, is people relying heavily on machine learning algorithms as a magic dust that they want to bring into the SOC. So they are trying to collect as much data as possible, and then hope the algorithms are going to find something interesting. The Google AI chief basically he said in an MIT interview that he hears that all the time. I've got this massive amount of data. Surely I can get some value out of it. And that's a massive anti-pattern. And in the security world, we have a tremendous amount of data, but looking through an ocean of data to find anomalies has not really made a huge dent, but it's still the focus. So if you listen to Google and kind of people in the machine learning world, artificial intelligence is really about perception, and it's also about decision making. And if you're going to make great decisions, you can't just rely on an algorithm for making decisions. You have to have good information to feed those decisions, and that really requires two things that the security industry has mostly ignored. One being the expertise that goes into that decision-making process. So you can easily get an algorithm to say these things look weird, but the more expertise you can push into the algorithm, it can get a lot more specific about why it's weird and separate out things that are just kind of flukes from meaningful security issues. And then the second thing is the fidelity of the data that you feed into the algorithm. So that really is the biggest challenge for SOCs. Both of these are huge challenges, like getting security expertise to aid in detection. There are very few people with the right skill set. They're very expensive, and they're very difficult for most organizations to attract and retain that kind of talent. But then getting high fidelity of data is also a huge problem. People get a lot of data, but it usually tends to be very low fidelity network level data or system logs that are as good as useless. Why is that? Like in a Windows desktop, you can do a lot better, and the EDR world helps you do a lot better. If you're looking at people's production infrastructure, though, everybody's been afraid to roll out anything that would get the right fidelity of data or really do the right fidelity of zero-day detection because, like I said before, the security of your workload is vastly less important to an organization than the reliability and performance of that workload. And so SOCs are just kind of like a third-tier concern for the business overall, and so they just have to make do with a lot of data that's very low fidelity. And so that really is driving this kind of alert fatigue problem and makes it really, really tough to actually find 0 days and all of those weak, noisy signals. So, I think that when you hear people say, oh, well, we need to bring a lot of data back to the cloud and analyze it, and that's how we spot new stuff, that is, in my experience, having done that several times over the years, that's all marketing. It never really provides the good insights. Staying close to new vulnerabilities, new research, watching what the Black Hat community does tends to drive better detection than trying to leverage algorithms that are essentially commodities, if that makes sense.
Well, you mentioned MIT. There was a story that MIT published about a week or so ago, I think it was, that because there's such a dearth of security professionals and there's such a need that some universities and some companies are starting to invest in AI software, and they're essentially hiring gamers who are accustomed to, staring at screens all day and just using them to run the AI software to look for anomalies because they can't find trained staff, which I guess is good in some ways, but you really do need experienced and trained analysts to be able to tell the difference between an attack and just somebody who's, maybe working from a different location and pinging files. Yeah, for the most part.
100%. Go ahead. I think that's 100% right, and that's challenge for security is only going to get worse over time. So to illustrate your point, if you dump all your network data into algorithms, you can definitely get anomalies that bubble up, and sometimes those anomalies will relate to, okay, there does seem to be some server that's beaconing out to China, and that turns out to be a real incident. But a far greater percentage of the time, it turns out to be something unexplainable that isn't actually bad, and getting to the explanation requires a lot of shoe work for almost no payoff. And that problem is going to get worse as more organizations move to a continuous deployment model, because if you're looking at anomalies in a network topologies are going to change more and more often because people are deploying even at the application level multiple times a day in ways that could change the topology. So, really it is the expertise that you need, and you can either apply that expertise after an algorithm points you in a very rough direction because it doesn't have the expertise, or you can drive the expertise first and put that into the algorithm, and that turns out to pare down your workload dramatically. Like, that's how Google does it and in their own security operations. And the traditional SOC for a company that size, you might expect like a couple of hundred people that are not very technically skilled that do triage. Google isn't like that at all. They've got a small team of developers that maintain all their automation, and sure, they investigate incidents, but there are very few things that aren't covered by their automation because they let the expertise drive the algorithms instead of letting the algorithms lead and then hoping they can find expertise to work the events.
We've talked a little bit about this already, but when we're talking about 0 days on-prem networks, and we've talked a lot about moving to the cloud, but moving to the cloud does create multiple additional vector attacks or vectors for attacks. Considering that as a client, you don't have physical access to your cloud provider's network and can't actually do anything proactively to protect that infrastructure, what can you do to protect your data in the cloud from being attacked by 0 day? We actually don't have much time, so if you could give me the Reader's Digest version of this one.
This is the million-dollar question, and why a lot of big financial institutions that are very compliance-driven haven't pushed much to the public cloud yet. You could do the virtual appliance model and try to route everything through a virtual appliance, but that performs poorly and doesn't improve the level of security, and we're technically much more capable of that. So there has to be technology that is aware of what's going on in the cloud, essentially endpoint software running on cloud instances, but that technology needs to prioritize the reliability and performance of the workload over security, and that's what's missing in the industry today. So that's kind of the problem that we and others are pushing to solve, and what I think needs to happen before these compliance-driven organizations can really get comfortable that they're making best efforts in the public cloud.
For smaller companies, mid-sized companies that the public cloud is the only option, is there anything that they can proactively do to protect themselves more than they're doing today?
Well, generally they should find a good provider that can help them tackle these issues, that will provide them some protection if anything does happen to be an issue. So someone who's willing to cover the reliability there. So that really is for a small to medium business. It becomes even harder to stay on top of the technological trends, and finding and attracting the right talent becomes harder too. And these technological problems. Not many people have solved them the way that Google solved them, and we shouldn't expect to see that for a while.
I mean, everybody doesn't have Google's, pockets? Pity.
Yeah, exactly.
As much as I'd like to talk to you about this more, John, we actually have run out of time. I'm sorry we didn't get to the questions from the audience. All of the questions that you have submitted will be turned over to John and his team. They will be able to get back to you after the event. I'd like to thank everyone for joining us this morning. This is a great topic, and I hope we can explore it more in the future. So this does conclude today's 2020 webcast, 0 Days and Counting. Good morning, good afternoon, good night, wherever you might be. Thanks for joining us. We'll see you again soon.